Okay, if we preview it, they are two-sided, and then we can offset the mesh for some certain distance. It can be negative or positive. Okay, let's see. And basically it follows the normal direction. You can have negative or positive. Okay. This offset is also very useful. Offset, well, distance with chamfer corners. We have a mesh. Mesh like this. And then we offset it. Control the distance. Okay. And then we chamfer the corners. Make it smaller or large. Okay. You see, for the intersection of these panels, it will be very difficult to construct when you have many surfaces joined together at one vertex. Okay, so a reasonable way for fabrication and also construction is to chamfer the corners, and then you have another element to fill this part as a joint. Okay, and we can loft these chamfered offset panels, and then this is the structure we get afterwards. Okay, maybe we can preview it. Okay. So the corner of each of these hexagons are truncated. And then we have this hexagonal. Oh no, the triangles are truncated. So we have these hexagonal holes in it. Planar offset works with 3 valence closed mesh only. For n larger than 3 valence experimental component. Okay, so they are not quite sure if this component will work or not. Okay, when the valence is larger than 3. What is valence? We have mesh. This is dodecahedron, right? Consists of 12 pentagons. Is this the 3 valence closed mesh? This is a closed mesh, of course, right? Because it encloses a volume in the 3-dimensional space. But if this is a closed mesh with 3 valence, yes? I think I have explained what is valence before, but if you don't remember, you can make a guess. What does it mean by 3 valence? 3 valences. Take a look at these vertices. How many surfaces are intersecting at this vertex? How many? 3, yes. Or you can count edges coming out from this vertex. 3, right? Okay, so this is called 3 valence. So if all the vertices are of 3 valence, then this is a 3 valence closed mesh. Okay, And this algorithm will work for this. So we weld the mesh, okay, the default, wow. Radius for welding, okay, I need to figure out what does this really mean. I just figure out when it is negative or positive, then it means that it has to duplicate or triplicate or even with more times the vertex. But what does it mean by 0.001 radius for welding? Okay. Anyway, now we can offset it by 3. So it creates another mesh. Okay, and then which is the offset of it? Okay. Okay, why they need to take this? Okay, why? This is weird. Not weird. I mean, if you understand it, then it is not weird. You see this data structure. It consists of many polylines. And then the output of it, it organizes the polyline by matching each of these pentagons. And you put each pair of it in one branch. Okay? And the important thing is that with this list item, you can have I and plus 1. So then you create 2 output, each for one of this pair. One of the polyline in every pair. Okay. This operation is exactly like if I do it the other way. I go to set, and then I flip the matrix. After I flip the matrix, I get a tree with 2 branches. Okay, and then I explode it. I exploded the tree. Okay, usually we do this match output. Then we get the first branch, second branch. This one is equivalent to this. Okay, but somehow this is very compact because it uses only one component to do the same thing. Usually I do it this way. It takes 2 components. Okay, so this is a kind of smart way of using this. Okay, although you may think this is a strange way, but it works like this. So with this, we can take the inside polygon and also the outside one, and then make loft to them. So in this way, we create all these panels as pentagonal panels. Okay, let's check another one. Break. Here, this is a break. Untrimmed surfaces. Somehow why it is not filled? Okay, anyway, the shape. Quadrangle division. Okay, we divided which quadrangles with the U value. To polyline, convert them into polyline. And then make them meshes again. Why? 6650. 6650. When you clear it, then they are divided into triangles. Okay, you divide them into triangles. This is interesting, and then you find the dual of it. Now they become hexagons. You see, the relationship between triangles and the hexagons. Some of them hexagons, but here you have pentagon. Why? This corner, what is the valence of this vertex? 1, 2, 3, 4, 5, right? So if you have a vertex with valence 5, then when you find the dual of it, you get pentagon. For others, for example, this one, the valence 1, 2, 3, 4, 5, 6. The valence is 6, then you get hexagon. Okay? So this dual operation is quite interesting. Because usually for mesh, we need to triangulate the mesh. Okay, but triangles are not, I would say it's not so friendly for building construction. Okay, because then you have sharp angles, which is difficult to fabricate, easy to broke. Okay, but if you find a dual of it, then you convert a pattern with triangles into polygons with more than 3 sides. Okay, corners, you find the corners of them. Oh, no, the corners of the entire surface, not the panels. Okay, you simplify the mesh. You fix this, and then you simplify the mesh. Now it's 200 and 364. Okay, you get less vertices and less panels. Okay, and I think the resulting mesh is more useful for construction. Triangle mesh, where are they? Oh, now we have the face and the rabbit. Okay, we just try with the rabbit. You weld the mesh. So now this one you have 502 and 1000. 502, 1000. Okay, you don't change anything. The radius 0.1. Okay. You find the dual. Okay, this bunny is triangulated mesh, right? And we find the dual of it. Now they become hexagons with pentagon depending on the valences of all these vertices. You get the frame of it. Remember, we have been using this frame. You can change the distance, okay? And then from this polyline, we create a mesh. We create a mesh. Or you want the panels, right? This is another one of getting the frame, okay, but by default it's using this one. You join all of them, so it becomes still many. Let's take a look at the data structure here. They are separated into branches. So I don't get why they want to join it, because it does nothing. Okay. Anyway, clear means to clear the NGon definition, so it brings it back to the quadrangle surfaces. These are all quadrangles. Okay, and then create NGon mesh back. Flatten it so that you can join it and weld it and then show it. Okay. So now you get this bunny with red color outside and gray inside. Where is it? Oh, it's far away. This is another surface. I think there is something wrong with the rendering engine. It shows only the boundary, which is weird. Okay, so this diamond divide, we have also do something on that. Okay, get polyline of them, and then bring it back to mesh again. Let me centerize the rotation. NGon centers. Find the center position of all these NGon. It is interesting because here for each point it shows a small dot, right, instead of a small cross. Okay, find the closest points along this line for all the points. Okay, it wants to create variable frames. Let's see the result first. Okay, now it creates a panel like this. But when you take a look at it, you see the thickness of the frame are variable. Right? At the middle part, the cavity is larger, but at the boundary, the cavity, the size of the perforation is smaller. So you need a way to control the offset distance when you're making the frame here. Okay. So here the computation here using the curve and calculate the distance between the center of this cell to the curve to decide the sizes of the offset when making the frame. Okay, so you get the result, then you have different thickness for the offset frame, and you can control this by modifying the curve. Okay. There are many different ways, or using attractors, okay, something for that. And after you create this thing, somehow I think the computation of these two components takes a while. So it uses here a data dim. Okay, so when you change something, let me change something. For example, I change the UV value. Okay, you see the data dim become a triangle, which means the data flow is stopped here, like the river water is stopped by a dam. Okay, when I change something here, then the data is changed. Okay, so actually regularly it should flow through and then activate these two components. But because these two components takes a while to do the computation, so we use a data dim to hold it until we have finalized all the changes in the part in the upstream of this dam. Then we decide, okay, I would let it through, and then I open the dam. Then it starts to take the computation. But here they have a double insurance because they disable this component. But if I enable it, and it will do the computation. It offset the mesh. So before it is 0 thickness, now it has some thickness, and then we can preview it. Okay. So, okay, let me finish here.